Uh, Hello. I will start maybe after 5 minutes. Hello, welcome to the session. I'll start the session after 5 minutes. Okay, so let me start the discussion. So at first, I will go through like pointer in structure. Then I will do a coding on neutral option, and then I'll discuss some previous week assignment because the course is already in the last week. So like you probably would have solved, like already have solved the problems, but I'll still discuss them again. Whatever the like assignments were there in the previous weeks, and if you have any doubts, you can ask me. So pointer in structure is basically it is quite similar to the pointers in like let's say integer or like float or character. So at first I'll just go briefly about structure again. So basically, in structure, we have all, we can have multiple data types. Let's say here integer, character, float, all three we can have together. But let's say if we take array or any other data type, like it should be homogeneous. But here it is like heterogeneous. You can have anything. So that is the basic like need of the structure. And uh, obviously, like we can use multiple arrays. Like let's say we can use maybe if we need three roles, we can obviously use like a role is an array with three members. Department code is again an array with three members. CGPA again array with three members. But like doing that will make the code very complicated. So and also like suppose you're shorting those things. So suppose you are shorting according to the roll number. So you have to keep track of the index. So however you are shorting according to roll number, you have to again swap department code and CGPA like that. So and again they like roll number will be in a contiguous location, but department code will be in a different location. So stuff like that. So structure is used to like allocate the memory where like everything is like being stored together, and like it is a single object which is holding all three: roll number, department code, and CGPA here. Like just for example. So okay. So what is array of structure? So array of structure means, let's say I have a class, okay, and I in the class I have 100 students. So what should we do? One way is that just define like student A, student B, student C, like that, like 100, like 100 variable names. But that is not really good approach because like there is no mapping, right? So you have to remember every variable. They like it is very difficult to like apply same thing to them like consistently. So similar to the like just like any other data type, like you can apply like array concept here. So basically, see, structure is a user-defined data type, right? So basically, this is this student is a data type, just like integer or float, but instead of like it being a single type like integer or float or character, it is a combination of all. So most of the things that we apply in the integer arrays or like character arrays, those mostly are applicable or like a structure as well. So how to define a like structure array? So let me just go to the coding. Let's say I have a structure already. Okay, let's say uh, struct. We have a class, class. Okay, here it is student. So let me go student only because class I'll be using somewhere else. Student. It has a roll number. Okay, let me just copy paste this three. Okay. So this is a data type. Okay, one data type. And let's say assume some other data type. Let's say I want to define integer array. So it is like int int class 100, right? So what is different in structure? Suppose like I just want to say only one, let's say roll number and 100 students. So I'll do like this. But how to do it with structure? You have to do it like this. So struct student, then you have to give a variable name. So this is the data type I want in a variable of type student, structure student. Let's say variable name is class, and I want it to contain 100 like values. So that means I have 100 roll numbers, 100 department codes, and 100 CGPA. Okay, so this is it. Also, alternatively, you can always use type def. Like with type def, you can give a different name for this, and instead of struct student, you can use that name. That is always possible. So here, see, like syntax is quite similar to the like primitive data types. It is instead of integer, I have just used struct student. That's it. So now what happens is that it will allocate the memory for like all the like 100 members. So let's say if I want to access the like first student, what should I do? Class of 0. So this is the first member. Then I have multiple things like role is one variable, class of 0 dot name is another, sorry, department code. This is another class 0 of like, CGPA. So these are the like other values. So it is quite similar, like just like A, B, and C, like how to access A dot role. b dot roll and c dot cgpa. So instead of abc, we are just giving class 0, class like class 0, maybe for first student, class 1 or maybe for second student, like this. So it is quite similar actually. And this I have discussed already. Like you just need to do it like this: class of I, which is the index number of the member you want to access here. So this is it. Then okay, so I'll show an example. Let me code it from scratch only to sort an array based on structure. So, like let's say I have an array of, just a second. I have an array of structure and I want to sort it via roll number. So let's say I'm having this one only, right? This one is the structure right now: roll number, department code, and CGPA. And let's say I want another structure here, like array structure. So struct student, like this is data type class. I maybe have 100 students. Okay. Okay. And then let me take some inputs from the user, maybe enter the number of students in the school. Okay, so this is done. Then scanf. Let me just take some value here, int n maybe. Scanf here I have percentage d ampersand m. So basically this is just a variable where I am storing how many number of students are there in the school. Then I have to run a for loop and read like each of their, let's say, roll number, department code, and CGP. So let me just run a loop for okay, let me just check I. Int I equal to 0, I less than n, and I plus plus. So I have to read what I have to read at first roll number, department code, and CGPA. So let me just write printf, write the roll, DPT code, and CGPA. So it will run for like let's say if I give 5 names, it like 5n, it will run for 5 times. And now let me read the values here. So I'm trying to read 3 values at once: roll number, department code, and CGPA. So how to do this? Roll number is of integer, so percentage d. Then a space. Space is like it will delimitate the like input string. So percentage d space department code. So department code is what? Department code is of like string type, right? So it should be like it is character. So it is character, right? Should be like percentage s. Then this one CGPA, this is like float, right? So it is like percentage f. So basically what we are saying is that at first we'll like whatever the input is there, we'll read it. Whatever is there till a space, will before that we'll consider that as integer. After that we'll consider that as a string, which is a department, and then just so these 3 are the variables that we're trying to read. And after that, we have to store them into the respective places. So let's say, what is the respective place here? Class of I dot roll number. But since this is an integer, we have to we have to actually give the address. So in this address, it will store the integer roll number. Then class of I dot dpt code. So this is a string of characters, so we don't need to give an address here. and then we have CGPA. So this is like, again, you have to give the ampersand and class of I dot CGPA. So now reading is done. So let me just try to print it now. Okay. If we have read it successfully. So instead of scanf, I am writing the printf. Okay, I don't need to give the ampersand here. Okay, so here I'm saying roll number, then PT, then I have CGP. Okay, and finally it's a slash n. So let me just try to execute that. Okay, I haven't given this. Okay, number of students, let's say 3, and CGPA of person 1 is like, let's say 1. Department name is like, let's say CSE, and CGPA is 8.8. Second person is 2, electrical engineering, and 9.1. 3, mechanical engineering, and 8.7. So see, like it has stored the 3 members into the structure. And now if I am printing that with the department code and CGPA class of I, so it is going through each of the index and it is printing the value. So this is like reading writing. So how to sort them? So let me describe that. So for sorting, let's say we can do any type of algorithm, like bubble sort is there, selection sort is there. So in my example here, I think I have shown what sort, selection sort. Okay, so let's go ahead with that. So uh, basically we have to run 2 loops. Okay, so for uh, int j is equal to 0, j less than n minus 1, j plus plus. So basically, like there is outer loop and there is a inner loop. Okay, so here for int I equal to 0, I less than, no, actually it should not be 0. It should be j plus 1 for insertion sort. So, yeah, equal to j plus 1, I less than n I plus plus. So there are 2 like nested loops, one within another. So now we'll come to the comparison. So basically what we are doing is that we are iterating through each of the values here from beginning to the end. And for each element, we will look at the next element till the end. And if like element here is greater than the element here, we'll stop there. So that's it. That's it, like a section shot. So so basically assume that we are using integer. Okay, so let's assume class is an integer. Okay, and we're just swapping them. So what is the logic? Let me write that, and then I'll change the logic to structure. So what should be the logic if class of I is greater than class of j? Actually, it will be opposite. If we want to sort from in increasing order. So if the like previous value is greater than the like let's say we're starting with first element, then we are going to like second, third, fourth element, and if that element is greater than the like first element that we are considering, so then we have to swap them. All right. So what is the like method for swapping? We have to take a temporary variable. All right, and we have to take a like we have to do it like this. Int temp is equal to class of j, class of j is equal to class of I and class of I equal to 10. So this is the basic swapping operation, but note that this I have done assuming that we are having integer or like float. It's not assuming that we have structure. So let me just copy this one only and try to rewrite it with respect to the class. So for class, what we have to do, we have to consider that we are considering roll number only, right? So all the comparison is with roll number. Okay. So class j dot roll, class y dot roll. Okay. And here it is not a int temp. Here what we have to do, we have to like this should also be a structure, right? Because like we want to have a temporary variable to store structure. So it should be what? It should be uh, struct temp struct student. Okay. And then temp is class of j is class of I, and class of I is temp. So these are totally fine. So basically what will it will do, it will check if the roll number is greater than the next roll number. If it is greater, then it will create a temporary structure. It will copy the first roll number here in the temporary. It will copy the first the value that we want to exchange. It will copy that to the j, and then again it will copy the temporary to the I, like this. So at this point, it should have uh, like shorted the array. So let me try to do it again, but I'll give the roll numbers haphazardly. So let's say number of student is 3. I'll give roll number 2 first, Amy, and maybe 8.9. Then maybe I'm giving 3, CSE, and 8.0, 1, E, 7.4. So you see, after the sorting is done here, it is giving like sorted structure. At first, roll number is 1, then roll number 2, then roll number 3, like this. So this is how sorting works. So this is basically exactly quite similar to the simple uh, like array or integer array or float array. But only difference is that instead of like integer, you have to temporary variable should also be structure, and you have to consider which variable which member of the structure you want to like do the comparison. All right, so let me move ahead to this. So I have already given the code here in the slides. So then let me talk about pointer of structure. So uh, pointer is what? Like pointer is something to store address of something. So if it is like if I write something like this, let me erase this. Let's say I have this, and I have an sorry, I have an integer like int a and star p, and p is equal to ampersand. So that means I have a pointer. I have a memory address which does not store any value. It stores address. So here it will store address of an integer. All right, but for structure, this concept is same only. So let's say I have a structure like struct student, just like before, and let's say role, then character, department name, DPT name, 5, and I have dot CGPA. So how to define an variable of structure type? So this is basically, instead of doing this, let me do this. So if I want to define A, so it is like struct student A, right? And if I want to define a pointer, what is the syntax? Struct student start, like this. So see, stress like syntax is exactly same to the primitive types only. Just instead of integer, you are writing struct student. So I can combine this two. I can write it like this only. This is also fine. So let me, instead of defining a single thing, let me define maybe class only, class of 100 students, star p. Okay, so now initially what the pointer will do. So let me say pointer is, let me define pointer as a pointer is equal, sorry, p is equal to ampersand of class. So at first it is like it is being assigned to the first member in the structure. Okay, it's not even need to give zero. Like by default, it will point to the first class, like first starting address. So then let me go here. So basically, let's say if I do pointer plus plus, okay, if I do pointer plus plus, like or p plus plus here, I wrote p here. So assume that this is 4 byte maybe. This is okay. Let me skip that. So like what will happen if you do pointer plus plus is that it will increment. It will increment the, like, let's say it was currently it is at like memory address 10,000. If you do this and let's say assuming struct size is maybe 40, and this is just an arbitrary number. So every time you do this, it will become like 10,040, then 10,080 like that. So just like integer pointer, every time you increment that, it will like address will get incremented to the next available integer, right? So same for the structure as well. So it is like not really too much complicated because everything is quite similar conceptually to the like integer or float or even character. Okay, so now there are two ways to access the variables, like access the members. So mostly I have used the dot operator, like uh, let's say to like access the student, first student roll number. So what should I do? Like class of zero dot roll. But there is another way. Uh, there is arrow operator. Okay, so I can, instead of roll, I can also do this one. But one thing to note here is that arrow operator and dot operator are see here. Uh, Here I have given the structure. So class of zero dot roll. Okay, like if I give percentage u, let's say I'm giving p dot roll just for illustration. Uh, Let me also forget about all this. Let me just keep it as it is. Okay, so it is throwing an error, which it should, because p dot roll, it is meant for okay, sorry. I should not write percentage u. This is like percentage t. But again, it should throw an error because okay, let me give it like this. It should throw an error, but it is throwing wrong kind of error. Okay. So basically, see, P is a pointer. I cannot point to the pointer and then I can say that give me the role. I can do it like this, class of 0.role. That is fine. It should run here. Uh, Let me just cancel this one. Just a minute. At this point, I don't even need the class. Okay, I have given, it should be semicolon here. Okay, so here I am getting correct, like I'm getting the roll number. So the first student has roll number 1. Okay, but let's say I am assigning this as a star P. Uh, P is equal to ampersand of class. Okay, I'm assigning that, and if I try to write P here, that will not work because dot operator is meant to work on like not real and pointer. So if I want to give a like try to print a roll number with respect to the pointer, we have to dereference that. Dereference means pointer actually stores an address, right? It does not store a value. So at first I have to go to the address where it is being stored. And so this is it star p. So star p will actually calculate the and go to the address where the class of like the first member is stored, and then it will print the roll. Okay. So now it is printing the roll. Then so this is one thing. Second thing is that if is there any alternative to this? Like instead of pointing it like this, start p within bracket this. There is an alternative. You can instead of using dot operator, you can use this p. So this should also give the same output. So one point to note here is that if you are using a dot operator, then you have to at first dereference it because pointer is actually an address, but we want the actual structure. Okay, so we have to dereference it first, and then only we can like get the value. But instead of like in case of this operator, arrow operator, you it is like dereference is implicit, so you don't have to like write star here or anything. Okay. So one thing to note here is that if there are like a dot, if there is like arrow, if there is a star, so like this one arrow has the highest priority. So here, if let's say if I have some nested something like I have one statement where I have all three. So the first priority of operation is like given to this one. Then it is like dot, and then at the end it is dereference. Okay. So is let's say if I do it like this, let's say p p dot start p dot roll. Okay. So this will not work because p dot roll will come first and then it will try to dereference. That is not acceptable. We want start p to like p to dereference first, then only we can get the growth. Okay. So then it will give some output. So let me move forward from here. operator precedence. Okay, it is done. Then I'll come to Newton-Raphson method implementation because someone requested the same for like in previous week. So basically, let's say we have an equation and we have to find the root of the equation. So let's say, let me just take a arbitrary equation. Let's say maybe in the example, I think I have used, okay, I think I have used an example here, quite long equation. Okay, so I have used x cube minus x minus 2 as the equation. And so for Newton option, we need two things. One is the equation that we are trying to like find root of and its derivative. Okay. So how it works? So at first, like we start with initial a random guess, or like not really random. It can be like anything. You can get the guess from like a bisection method as well, any other method. So you have some guess at the beginning, okay? And what you have to do is that you have to calculate the slope, which is like the f prime x of x0. So basically, this is like you have to like f is the equation. F is the like let's say equation that we are trying to find root of. You have to take the derivative of that with respect to the x, and then you have to find the value of that with like current value, like first case of this. Okay. So now with that, we'll have a tangent which hits x-axis. Okay. So that will become your next value, like which will become x1. So x0 minus the like actual function divided by the derivative of the function. Similarly, for the next step, you will get x2 will become like the previous value minus the function divided by derivative of the function. Okay, so let's say for the simple case, it is like x square minus 1, and this is the equation. So what is the derivative of this? Derivative is like x square will come here and x will be stay there. So like it is like 2x. So assume that initial guess is 5. Okay. So what is f of x? 5 square minus 1, which is 24. All right. And f, f prime is, which is 2x. So this is like if we put value of x is equal to 5 here, it is like 5 into 2 is 10. All right. So what will be the new line, like a new point for our next guess? It will be x, which is 5 minus 24 divided by 10. So 24 is the fx and 10 is the f prime x. So this is like 5 minus 2.4 is 2.6. So before going to code, just give me a minute. Okay, so these parts I have already discussed, like xn minus f of xn divided by f prime xn. So let me go to the coding part right now. So before coding, like if you look at the example here, so this is like initially, let's say I want to find the like root of x square minus 4. So initially we start with 6. What is f of xn? Like you just use like 6 here, 6 square minus 44. So 6 square is 36 minus 4 is 32. This is done. Then this is like 2x. So 6 into 2 is 12. This is done. So if you take f divided by f prime, so 32 divided by 12, so this is 2.667. So the new value will be 6 minus 2.227, like 2.667. So the new value will be 3.333. So again, if you calculate, if you give x here minus 4, it will be like some other value. Some other value, if you take the ratio, then it is like 1 point something. You have to subtract this one from this one. Like this, it will continue, and you will stop when like you have some threshold where it is very close to, like it is not really changing this one, or when you have done the maximum number of iterations for your use case. So let me try to write this code. So at first, let me define two functions. Okay, so let me say in the example that I have shown you, I'll try to write it from scratch again. So let me copy the equation here at least. F of x is equal to this one. So this is like float, or maybe let me take double only. Double is the equation. Okay, double equation. What is the input? Input here is it is or maybe just write it only. Double F. Input here is x, and x is not necessarily integer. It can be like just in the previous example. It can be even if we're starting with some integer value. This one, or like after performing some steps, it will ultimately it will come to the floating points. Okay, so let me take this as a float only. Let me do this one. Let me do it as a float only. So double float here, it will come double x. Okay, so how to define it in this way? So what we have to return? We have to return x into x into x, so x cube minus x minus 2. That's it. So this is a function that we are trying to define. Let me also define a derivative of x, double of maybe d del f or df. We have to give x, then what is the derivative of x here? So if prime x it should be, so if you take derivative of x cube, it will be like 3x square, right? So it will be like 3x square minus x will become 1, and minus 2 will get 0. So the derivative of like f is like 3x square minus 1. So I have to return that. Return x into x minus 1. Bracket is not required here, but I'm giving it anyway. Simple there as well. So now this is the I have defined both the functions. So let me try to guess some random number, and then try to use this equation to get the actual value, the actual root. Okay, so let's say I need two things. At first, I need at least I need two variables. So one is the current value of x at the beginning. So let's say x0, double x0, and the next value. So x next, or maybe x1. Okay, I'm taking. So after taking, let me also define how many iterations I am doing. So int max iterations, maybe 100. So it is not, it should not be like that. If it is not giving an answer, it should not run infinitely. It should give an approximate number. So I'm saying that I'll write the logic after some time, but the main intention here is that if it is has not burst till 100 iteration, then just give me whatever value you have got after 100 iteration instead of the logic here. Okay, and then let's say int for a double tolerance. So tolerance means like if the value is not changing much, then tolerance maybe, let's say, let me just define some very random value or like very small amount, and if it is not changing by that amount, then like we'll stop that. Yeah, the like root is not changing even after like multiple steps. It is remaining very similar, so there is no point in like costing the time and compute. Okay, so let me go ahead. So let me actually take the initial guess. Let's say x0 is maybe what will be out of the equation. Maybe let me just take anything like 0.001. That is, let's say, my initial guess. Okay. And tolerance is maybe, I'll just hard code a tolerance here. Tolerance is maybe, I'm just giving it just a high enough number. So x0 instead of like x0, let me just ask it from user only. So because I want to run multiple times later on. Printf initial guess. All right, and scan it. We have to take a long flow because it is like a double, and we have to, it is like x0. So initial guess, I'm taking it from the user. Tolerance, I have already like predefined it. And number iteration is like I also have predefined it as 100. Okay. So let me run the basic logic. So for int iteration is equal to 1 or 0. It is like I'm just trying to write for loop here. Instead of I am using iteration because I wanted to use I later on, maybe it might be different. So just read it as if int I equal to 0, I less than max iteration I plus plus. Or maybe just, I think I don't be using I anywhere. So just let me use that. It does this. Okay. Okay. So now what is the equation of this? Let me go here. What is the equation? Equation here is that xn plus 1 is equal to xn minus f of xn divided by a prime xn. So at first, so what is the next value that we want to print here? So let's say the next like value for the next iteration is x1. So x1 is the next. So what is the formula? X0 minus f of x divided by f prime x. Right? But I have defined f here, so this is fine. F prime is defined as df. So this is exactly what we have to calculate. So basically, x0 is the previous guess, and this is the function, output of the function with the current guess f of x is 0. So at this point, we are operating with the previous value, and based on the slope of the previous value, we'll update the we'll get the next value. All right. So and this is it. So at first, okay. So this is the next value. Now let's say let me also define it like this. So this part is done. But before that, let me also define it something like this, that Okay, so um, okay, so one condition is that if it is it has already completed 100 steps, then it will obviously print. Okay. Let me come to the like stopping criteria later on. Let me just print whatever is happening here. Okay, so x1 and x0 and fx and dfx. Okay. So let me say iteration iteration uh, percentage d, then slash t is for tab. Okay, so iteration is this. Then let's say x0 x0 percentage d slash t. So I want all the values. Okay, so what is the previous value? What is the current value? And then let me calculate, or let me actually store them in the variable so that I can print it. So let's say double fx is equal to if of x0 double dfx is equal to if df of x0. Okay, so here it is like fx, here it is like dfx. Okay, so here at first it will be like ith iteration. Then we have the x0, then we have the fx, will print the dfx. I'll come to here, dfx, then we'll print, uh, okay, let me just print it right now, this only. So at first it is like I, so percentage d is fine. Then x0, so that is uh, like double, so that is fine. Then if x0 fx is like if x is also double, it will return double only. So uh, sorry, I should not, I should be using like percentage, not percentage, it should be long term. Percentage LF and tab dfx is also is equal to percentage LF, and at the end I'm giving in. Okay, so let me just run the partial code. I'll come to the other steps. Okay, so double df of, okay, I have to give the same color here. Okay, so I have not given the initial data type. Okay, so let me provide the initial guess as maybe 2.0, you know. So see what is happening. This is not quite legible. Okay, so let me remove this things. Not properly understandable. Iteration is fine. Percentage D, then let me run it again. Okay, and this is iteration. This is x0. This is fx, and this is dfx. Okay. Into x0. Sorry, iteration slash t x0 slash t fx slash t dfx slash n. Oh, sorry, I have to give this outside. And outside of the folder because I want this to be the header. Okay, so okay, so formatting is correct right now. So that's not the point. So see, initially everything is 4 only. It is not changing because I'm just calculating the x1, but I am not updating the x1 with respect to the uh, I'm updating the x1, but in the next step also I'm using the same x1. So what we have to do, I have to define x0 is equal to x1. Why? In the next step, we'll use the like new value of the x into the as the x0. So see what is happening. Every time I'm getting a new value of x n plus 1. So now I'm using this value I'm using here. So similarly, whatever value you have got here, x1 will be using that in the next iteration to calculate this one. Okay, so let me again run this. So initially it was like 4. In the next iteration, it become point like 0.1333 like this. Then it become negative, something like this. It is like jumping around. Okay, so till 100 iteration, and it is unable to like find the root yet. Okay, so now let me talk about the tolerance. Here I have told let me just find the root of x square. Okay, let me just keep in other thing. Let's say if I give 1. Okay, so now let's say I'll check if uh, I'll check the tolerance. So basically, what is tolerance here? I'll check the dfx okay, just a second. So I have to calculate the error. Okay, so error means is x is changing with respect to like suppose initially the x was 5.55 something, and after the next iteration it is like 5.5556 like that. So if the change is very small, then we can say that it is not really changing like anything meaningful. Okay, so then we can just stop it there and there only. So what should we do here? Before doing this, I'll check the difference between x0 and x1. So if x1 x1 minus x0 let me just define an error or like a double change. What is the amount of change at this iteration? So double changes if like x1 minus x0. All right. So I have to take absolute value if abs. Like even if it is negative, we'll consider positive only to do the comparison. Then I have to check if change is less than the tolerance here. If change is less than the tolerance, then you can just break that. Like it is not changing much, so there is no point in guessing further. Right. So okay, so this is there. Let me just do it like this. Tolerance reduce. Okay, I have to include math.h for absolute effects. Include math.h. Initial grace may be 3. Okay, one thing, there is a mistake here. So basically, this is 3x squared. So I have just given 3x squared minus 1. This is not correct. So 3 into x squared minus 1. Let me run it again. Let me give equals like this. So let me also write it like this before breaking. Printf tolerance criteria reached. Then let me write this. Printf x0 is what? Percentage LF. And here I have to write x0 x1. Okay, so again, let me give 4. So basically, what happened here is that initially it was 4. Okay, so this also let me write. Let me add some other variables as well. Let me try to make it similar to this one. So xn we have, if xn we have, if prime xn we have to write del x, and we have to write x n minus 1. Then you can. Okay, so let me give the additional information here. Uh, here. Here. So what are the additional information here? Additional information here is the percentage t again, and we have to give here this one del x. So del x. Sorry, this is like let me write it here. Slash t del x. Okay. So here I have to write again LF percentage LF. So what is del f? Del f here is like fx divided by dfx. Fx divided by dfx. This is also I have written. And let me write the new value as well. Percentage t. It is like slash t. X. So it is x1. So I'm just writing all the values in like in a table format. So let's say my initial case is 3. So this should not be D, it will be F. So okay, so initially I started with 3. This is the like fx. This is the like derivative of fx, and this is the ratio. Like this is the slope. And what is happening is that this minus this is this. Then again this minus this is this. And at some point, what happened? Like the x0 and x1 is not changing that much. So there's no need to go till 100 iterations, right? So we'll just stop here. If I give some other number, let's instead of here, let me give 10. So it will take some more iteration, but still it is quite fast and we are getting the same code on. So even if the initial guess is somewhat uh, far, it is fine, but if it is too much far, then that may not be working. So, okay. So if I put 10,000 as a guess, it is conversed quite quickly. So if I look at the previous example, so let's say this example, okay? And if I want to find the root of this instead of this equation, what do we do? We just let me just mm, replace this function. Double of a is equal to double of x. Here, what was the equation here? This is x square minus 4, right? So I just have to return it like this. Return x into x minus 4. And I have to define double of fx. And the equation is 2x, I guess. So x squared, if you take the derivative is 2x, so return 2 into x. All right. So let me run this code. Okay, I have written df here, not fx. Wait. Okay, so let me take a guess here. Step 4. So let me take 6 only. 600. So see, if you try to compare it here, initially it was 6. After the first step, it became 3.333. So send here. Then after second step, it is like 2.67. It is like, yeah, quite close. Like there can be some numerical mismatch by this, right? Due to computation. And then in the second step, it is like 2.016. Then it is like 2.000 something. And then ultimately it is like 2.000. So obviously, like if you put this equation, like if you put 2 here, 2 square minus 4. So this is like 4 minus 4 is 0. So yeah, this answer is correct. So this code is working. So if you want to just like if you want to like calculate root of any equation, you just have to replace these two function. One is like function itself, and one another one is its derivative. Okay, so if you have any doubts regarding this, please feel free to ask. Otherwise, I'll move on to the next session. So I have already written the code. It is slightly different from how I have done right now. But yeah, you can look into this. So now I will be discussing about the like I have already discussed the previous year like assignments in the like Tuesday. So that's why I will be discussing about this year assignment like solutions. So almost like mostly you have solved this assignment already, but I'm going through this again. And if you have any doubts, you can clear them now. So this is the first question. I think this assignment I took from week 5 or week 6. So for this year only, right? So like this is a for loop, and uh, what will be the output of the for loop? Please like you can unmute yourself and write, or you can like write in the comments. I'll give us some time. Okay, like that one answer C. And okay, so C is actually a correct answer here. So what is happening here is that like initially, it is like for n equal to 10 in less than 10 in minus minus. So here like this condition, so because uh, in less than 10 it will this initially this condition is false, okay, so it will uh, not go like initially like it's 10 less than 10, so answer is false, okay, so this will uh, like it will get terminated, so like no output here. Okay. So which of the following is not a infinite loop? Okay, so yeah, answer is D. So basically see in case of in the first one, there is no initialization, no like checking conditions, so it will be an infinite loop. Obviously, if you don't stop it inside the for loop. Similarly, for here, there is no condition to stop it. So again, this will be like infinite loop. Same for while one. Zero is like false, so it will not go inside the loop at all. So it is like not infinite loop. Next question. Two and four. Okay. So this is totally correct. So obviously, like two while loop must be terminated by semicolon. This is true. Even if the condition is false, the do while loop executes one. That is also true. But do while loop is always infinite loop. That is not true because within the while loop, like within the checking condition, we can terminate it, right? Or like even if we don't give a condition, like even if the condition is true, we can just terminate within like break or something with break. And then like do while loop is entry control loop. So yes, like there is this is not really entry control because even if the condition is false, it will like execute it at least once. So entry is not control. So these two are false, two and four. So I'll come to the some sorting questions as well after going through the MCQs. So uh, here we have M and N, and we have two condition within while loop. So what is the significance? Will both of them be considered? And then what will be the output here? Okay. So answer here is 7 and 7 because like it is quite not intuitive. But the thing here is that in while loop, only the second like both condition will get executed, but true or false decision will only be taken based on this one. So suppose if you write m plus plus or anything else here, that will get implemented, okay? But like to go inside the loop or not, it is entirely dependent upon this one. n less than 7. So initially you are starting from 0. It went to 1, 2, 3, 4, 5, 6, 7. So even though m, like suppose at some point it is like m is equal to 5, n is equal to 5. So this condition is false, but that will not be considered. Only this condition is considered. Okay. So only when m is equal to 7 and n is equal to 7, then only it is being terminated. So one thing to note here is that comma doesn't mean that if both of them are true, only then it is true, or it doesn't even mean if either of them is true, then it is true. No, just the right one. It is entirely dependent on the right one, rightmost one. So answer here is that it will get evaluated from left to right, but the rightmost expression is used as a condition. So 7, 7 is the correct value. I have not written the answer. Let me just write the answer here quickly. Okay. So let me go to the next question. So there is a fill in the blank. What should we write here so that uh, like everything else other than 8 is printed? So yeah, your answer is right. So if you write continue here, it will just skip this. It will run the loop again, and it will like continue with 9, 10. So switch is obviously not applicable here. And if you write break, it will stop at 7 only. It will not go to 9, 10 like that. Exit will just exit from the program itself. So only correct option is continue. Okay, next question. There's a switch statement, and then there are some cases. Which one will be printed? Right. So basically, here note that there is a no break statement. Okay, so switch x, so x here is 0, so it will go to case 0. But since there is a no break statement, it will carry forward to case 1. Again, there is no break statement, so it will carry to like default. It will print everything. Okay, so NPT also, so MIT as all three, it will be printed. So correct option is C. Then question 7. So you have two things that are being initialized here, and there are again two conditions to check, and then again there are like two operators, two like increment decrement operators. So what will be the output set? Okay, 1, 3, 2, 2. Then all right. Yeah, you are totally right actually. So basically, what is happening here is that like there is no problem here. K equal to 1, J equal to 3, and K plus plus J minus minus both will get executed as when their time comes. But in this condition, K less than equal to 3 and J greater than equal to 1, same to the while loop, they will be checked. So this, but only J greater than equal to 1. This value is considered to decide if it will go inside the loop or not. So initially K equal to 1 and J equal to 3, and j is greater than 1. So this will get checked, but it doesn't matter in this case. So j is greater than equal to 1. So 3 is greater than equal to 1. So this is true. So at first, what will be printed? It will k is here 1 and j is 3. So 1 and 3 will be printed. In the next step, so what will happen? K will become 2 and j will become 2, right? So again, j is greater than equal to 1. So this is again true. This will not be considered. So 2 comma 2 will be printed. Now k will become 3 and j will become 1. So again, j is 1. 1 is greater than equal to 1. So this part is true. So 1 comma 3 comma 1 will be printed. K is 3 and j is 1. Then j will become 0 and this part will become false, j greater than equal to 1. So then it will be terminated at this point. So the correct option is like at first 1, 3, then 2, 2, then 3, 1. Okay, so next question. What will be the output of the following program? Right. So here 4 will be printed 3 times. So why is that? So there are two things like P is there in two places, here and here, different two places. So whenever the printing is whenever you are trying to access it here after within the for loop, tr- it will find the most local like value. So here, even though there is a P, if you look at if you imagine some kind of tree and the nearest one, like this is in the same level, right? This is one level up of that. So it will take the value from here. So it will print 4, but if you look at here, p equal to 0, p less than 3, p plus plus. So it will take the value from its immediate or like its parent. Okay. So immediate, we have one value at the immediate. So it's like here it is like it will take this p. So p is 0, p less than 3, p plus plus. So p here is 0 at first, then it will become 1, then it will become 2, then it is become 3. So this P and this P is different. They will not override each other, right? So, but the inner thing will be taking this one. The outer loop will take this one. So 4 will be printed 3 times. Okay, next question. Uh, for the given C program, what is the output? Okay, so the answer is B because let's say the user input is 7. So we'll check 7 percentage 2, 7 modulo 2. Is it 0? No. So we'll increment and continue. So 7 modulo 3, is it equal to 0? No. It will continue. Ultimately, at it will come to 6. Okay. And then what will happen? Uh, it will get incremented to 6. But at this point, this one is false. So 7 less than 7. So that one is false. So it will not go again. Otherwise, like if it is less than equal to n, then it would have printed this number is odd. But since it is I less than n, so it will stop at like 6. And whenever it is like at 7, it will like 7 less than 7 will be false. So ultimately, only this one will be printed. The number is prime. Okay, so this is last of the MCQ question. Then we'll go to some array-based sorting algorithm. So basically, we have some if statement, which is only considering if equal to 10, then it is continuing, and then I equal to 15 it is breaking. So which one will be the output? So, okay. So the answer is C, because you see I equal to 0. So at first it is like incrementing, then comparing. So 1 equal to 0 is 1 equal to 10 is false. So it will come here. It will print 1. Similarly, it will print 2, 3, 4, 5, 6, 7, 8, 9. Then in case of 10, it will not print anything because here the continue will come. Then after that, 11, 12, 13, 14, 15, it will print till here. But when this condition is true, 15 equal to 15, then it will break. And like this will terminate the program. Okay. So option C is the correct option. So now there are some 3, 4 questions about sorting. So first one is that bubble sort. So you have an array of 5, 3, 8, 4, 2. At like after the first iteration, what will be the like state of the array after first iteration? So I'll try to visualize this as well. 5, 3, 8. Maybe pausing this. Okay, any answer? No, I assume that I'm not talking about. So it is like entire outer for loop. Okay, so in bubble sort, what happens is that always the largest number goes at the end. Okay, so at the end of the first iteration, the largest number, which is 8 here, it will go to the this place. So basically, what happening is that uh, 3 and 5 it will get interchanged. So 3 will come here, 5 will come here. 5 and 8 will remain the same. Then, so here, let me go, start it. Let me go here. Okay, so this will get swapped. Okay, 3 and 5. Then the comparison between 5 and 8. So 5, 8 is greater than 5. So 8 will stay here. Then 8 and 4. So 8 will get changed with 4. Then 2 will get changed with 8. So at this point, 8 is the largest number. So last digit here will be 8. So 3, 5, 4, 2, 8. So remember that. So at the first iteration, what will happen? 8, the largest number will come at the last position. In the second iteration, what will happen? The second largest number will come at the second last position. Similarly, third iteration, third largest number will come to the third iteration, like third last position. So if I just uh, give the animation time, so you see, this is second iteration, and at this point, the second highest, which is 5, it came to the last, like second last position. Then in the next step, 4 will come to the this position like this. So this will be shorted like this. So the correct option here is that this will come to 3, 5, 4, 2, 8. So basically, what will happen is that if you try to do it from the array only without any visualization, 5, 3. So this will get exchanged. It will become 3, 5. Then let me just write it here. So 3, 5, then 8, 4, 2. All right. Then what will happen? 5 and 8 will get compared. These two. So this will remain the same. 3, 5, 3, 5, 8, 4, 2. Then 8 and 4 will get compared. So this will become 3, 5, 4, 8, 2. Then 8 and 2 will get compared. So it is like 3, 5, 4, 2, 8. Okay, so let me go to the next question. So consider an array, and we are talking about the insertion sort here. So what will be the answer when you're like inserting the third element? So what is the answer after third iteration? First iteration is inserting 12, second iteration is inserting 11, and third iteration is inserting 13. Let me also try to visualize this. Well, 11, 13, 5, 6. Okay. Right. So in insertion sort, what happens is that like at first it will consider the 12 only, okay? And like consider that is the array sorted till this one, till 12. So obviously there is only one element till now. Forget about this part, okay? 11, 13, 5, 6. So forget about this. Till this part it is sorted, so it's like, okay, it is fine, sorted now. Now it will come to 11. And the question is that, is the array sorted? The answer is no. So it will like push the 12 here and 11 to here at this position. Rest 3 will remain unchanged. Then about 13. So it will check, is it correct? Like 11, 12 will be there and 13, 11, 12, 13. So it is sorted. So it will remain the same. Then after that, 5, it will check, is it sorted? The answer is no, because 5 is coming after 13. So it will shift 13 to here, 12 to here, 11 to here, and then 5 will be stored here. Similarly for 6, it will bring the 13 to here. I'll try to run the program and tell you. So see here, at first 12 was compared, but 12 was like it was like singularity only, so it is unchanged. So now I am comparing with 11. Okay, 11 and 12. So 11 is lesser than, like 12 is greater than 11. So it will swap them. Okay. So at this point, these two are sorted. Okay. These three are unsorted. So now we are inserting 13 between 11 and 12. So 13 is greater than 11 and 12, right? So it will remain the same. So at this point, after third iteration, so remember that like for insertion sort, if someone asks like what is the like output after the third iteration, you just sort the first three things, okay? And the rest will remain the same. If it is 4, it will be like 5, 11, 12, 13, and at the end it is 6. Okay? So here, let me just continue here. So what will happen? I am trying to insert 5 between these values. So obviously 5 is greater than 13. So I'll change that here. Then again, I'm comparing, is it greater than? So 5 is actually lesser. So again, this will come here. This will also come here. Ultimately, you will get best at the first position. Yeah. Okay. Then same for 6, it will come here, it will come here, it will come here, and 6 will come here. Right. So this is how insertion sort works. It just inserts the value to the sorted array, partially sorted array. Okay, so next another question about insertion sort only. So assume that after fourth iteration, what will be the output here? Okay, at the beginning it will be 1, then so remember it is like we are talking about 4 iterations. Okay. Two, 7, 1, 4, 5, 3. No. So in insertion sort, what happens is that first 4 element will get sorted and rest will remain the same. So just like the previous, like you see here, first 3, 11, 12, 13, they are sorted, but rest are same. Similar to here, 1, 2, 4, 7. So this order will come, then 5, 3. So 1, 2, 4, 7, 5, 3. Okay, so this is the last question for today. So you have a bubble shot, and after two complete pass, okay, so what is the last two positions? Right. So if you remember, just I told 5 to 10 minutes ago, that uh, in bubble shot, what happens is that at first, in the first iteration, the largest value will go to the end. So already the largest value is 90, so it is fine. In the second iteration, the second largest value, so 64 will go to the end. So 64 will come here. So this is the like hint that each pass places the current maximum. So initially, this is the total array. 90 was the maximum. So this is done. In the second iteration, current maximum is excluding 90 is 64. So it will place the 64. Okay. So this is the end of the questions. If you have any doubt, please feel free to ask. Okay, Runga. So let me go to one of my previous slides. Cooperate maybe in 10, I think. Okay, so in Runga method, you have some equation and you have to not really equation, like yeah, you have an equation, but you have to find four case. So there are some formulas for that. So I'll come to that. So basically, let's say we have the equation here. Okay. So let's say you have an equation where uh, you have some initial starting point, like there is some interval, okay, and y0 is the value of the output. So maybe I had I had some illustration. Let me just check once before recursion. Okay, I'm unable to find the illustration here. Maybe I can present you on twist 7p. Okay, I'll keep it ready. Okay, neutron eruption, is it not clear like I have told today? I can explain it right now only. And okay, let me write this things. Trapezoid in Gakuta. Okay, now Newton eruption, let me explain today only. So because I already have this in the slide for today. So Okay. So basically, what is happening here is that, so let's say, let me draw a graph here. So let's say this is a stem. There is some equation, maybe something like this. Like this is a curve of the equation. So in Runge-Kutta method, what we have to do is that we have to find the root. That means at which point the value, at which point y, like the line is intersecting with the x-axis. That is when the value of y is 0. All right. So in Runge-Kutta, in neutron adaptation, how do we do is that we found f of x. So basically, let's say, let me randomly guess. Let's say uh, let me just give a concrete example. X square minus 4 equation. So let me just draw the diagram of the equation. So the x square minus 4 graph is not like this. It should be. Let me just draw it. Like 1. This is like 2. Okay. So x square minus 4, that graph will become like this. So root is at 2, so it will become like something like this. This is not as Pascal, I'm just drawing randomly. Okay. So this kind of like curve will be there. Wait a second. 2 square is 4 is 0. 3 square it will increase minus n square. Okay, it will not go there. So it will actually, it is, since if it is lower, okay, minus 1 square minus 4 is, it will come here. 2 square minus 4 is 0, so root is there. And 3 square minus 4 is 9 minus 4 is 5, so it will be quite steep actually, not like this, quite high. And 1 square is 1, minus 4 is like minus 3, and okay. So it will come somewhere around here. It is like a minus 2 square minus 4. It will also, it will come something like this. So when minus, it is like 0, it is minus 1, it is like minus 2. So even for the minus 2 square is 4, 4 minus 4 is 0. So there are like two roots, okay? So just for like simplicity, assume that initially you guess that you don't know what the roots are. You are just guessing. So initially you guessed the root is here equal to 4. Like let's say x 0, like your first case is equal to 4. Okay. So what will you do is that you will consider what is the y here. Y here is what? 4 square minus 4. So y here is 12, right? This is y. Y is 12. Now you have to calculate derivative of y. So what is derivative of y? So basically it is uh, like slope. So basically what is the equation? X square minus 4. So if you take the derivative, so what like uh, f of f prime of x is equal to, if you take the derivative, x square, if you take the derivative is like 2x. Okay. So 2x means you have to calculate x is equal to here 4. So 4 into 2 is 8. Okay. So we have to calculate the ratio that how much long jump should you take from 4 to somewhere. Okay. So 12 divided by 4. So your new point is like new point is, what was the current point? Current point, your initial guess was 4, so it is 4 minus 12 divided by 8. So it is like f divided by f prime, or derivative of f. So 4 minus, what is this? 1.5, right? So your next guess should be 2.5. So initially you guessed at this point, okay? Now you are guessing that no, I should start somewhere here in the next step. So this is like 2.5. I hope the calculations are correct. 2x is yes 8, and x square is if we take 4 square is 16 minus 4 is 12. Yeah, okay. So now this is the new value. So you just subtracted this part. So this is the slope, like uh, this is the thing that was subtracted from the initial guess. So in the next step, what will happen is that you should take the y value from here. So what will be the value of y here? So if you give this equation 2.5 square minus 4, so 2.5 square is what? It should be 6.25. Yeah, it should be 6.25. So here it is like in the next iteration, x is equal to 2.5. F of x is equal to like 6.25 minus 4. So it is 2.25. So if you take the ratio 2.5 minus 2, if you take the ratio 2.2, 2.5 divided by 2.25, so it is like 1.111 something. So let me just verify here as well in the present slide. Okay. So here we have to take the ratio. So the the new value will become, new value is equal to 2.5 minus this one 1.1, 1.1, like this. So see what is happening at every step. Initially my guess was here. Okay, now I understood no, my guess is wrong, and then I decided how much step should I, like I understood that I need to go left. Okay, but how much? So that is defined by x divided by like fx divided by f prime x. So initially I took this much jump, then I am taking this much jump, then I'll take another small jump, and after some point I'll come to the point where it is actually equal to 0. So this is basically the Newton option method. So you just have to calculate the fx and derivative of fx, and you have to take the ratio, and you have to just continuously minus it from the initial guess till you get the till you get the fx value equal to 0. So note one thing, initially fx was like 16, fx was 12, now it is 2.5. In the next step it will become even smaller, maybe like around 1. Or if I give you this example as well, fx initially was like 12, then it becomes 6.66, then it becomes 4.5. Every step it is somehow decreasing. Okay, sorry, I'm not talking about this one. It was 32, 7, 1, 0. So at this point, it is like almost similar to 0 only. And in the next step, it actually becomes 0. Like it actually we found the root here only 2. So if you put this number into the next iteration, it will actually become 0. So x square, which is 2, 2 minus 4 is 2 square minus 4 is 0, like this. So yeah, these two are the main important things. Like if x and derivative of x, you have to calculate, you have to take the ratio, and you have to continuously minus it from the like initial values. How many iterations should be there? Like there is a no well-defined things here. So basically, most if it is like in the question only, so it is there should be mentioned that this many iteration you should run one thing. In most cases, you will get a definitive value. So in this case, like if it is not mentioned, you should get a definitive value, right? So like here in this case, definitive value is 2.000. So like there is even if you run for 100 steps, the answer is not changing. Okay. Another thing is that if they have not mentioned the number of steps, you have to consider if they have mentioned that give the value up to this point of decimal, like up to 2 points, 2 decimal points, right? So let's say then you have to check like 2 point, let's say here 2.03, then it's becoming 2.02, 2.01 like this. So when you can see that these two parts are not changing, all right? So in this case, like you can stop and you can like write that as answer. But like also in this case, I would recommend that suppose they are saying that report the like root up to 2 decimal points. So in that case, you should consider 1 decimal point extra because like there is round up, round down. So for like safety, like you should handle like you should watch last like these 3 digits that if they are changing. If they are not changing, so that means that is the root, and you can just write it like this, like 2.02 here because we are like rounding up, or 2.016 only you can write. Like it is not like not necessarily you have to write till like if they have said that you have to your number should be accurate up to two digits. It is not necessary that you write 2 digits only. You can write more. Like they will check the like difference between the actual value and your value that you have written, and then they will check if the difference is between 0.01, right? So you can write in that. So x0 is 6. It is not really like it is arbitrary. So like you can maybe like let's say I'm saying x square minus 4, and I'm guessing maybe 6 will be a good estimate. I can start with any other number, like 1, 10, 10,000. So the thing is that if the guess is near to the actual number is 2. If it is near, then it will be very fast. If it is further away, so it will take time to come to the actual solution. But it is not necessary to like take a very accurate estimate. This is just a random guess. That is the like one advantage of neural adaptation. You can start at any point and you can still get the answer. What if the estimate is lesser than the actual value? Okay, that is totally also fine. So see, and they will check the absolute difference between like even if it is positive or negative. Okay, so if it is like within 0.01, the difference, then like it is correct. So like that again, assuming that they have mentioned in the question that you should write up to 2 decimal places. Okay, so time is up today. I will end the session now. But yeah, we'll have a last session on Tuesday 7 p.m. and I will discuss the trapezoid there and Runga Kota there. Okay, so please join if you can. Thank you very much for joining today.